All right, in this video, we're going to talk about the intersection of two graphs, specifically of a quadratic and a linear equation. Now, there's three different possibilities that could happen. Of course, the first being that the linear equation cuts the quadratic. The second would be that the linear equation is just touching the quadratic somewhere. And the third would be that the linear equation does not even meet or touch the quadratic anywhere. First thing I want to do is I want to talk about what this means. That is that when the line is tangent to the curve, we say that it's touching at one point. So if we ever talk about, or if you ever read about or hear about a line being tangent to a curve, that's this situation where you've got one line or one curve just touching another one at one spot. So just kind of skimming by each other. They don't actually cut through each other. All right, so we've got that out of the way. Now, what are we going to do? We're going to try to find, to begin with, find the coordinates of the points of intersection of these two graphs, x squared minus x minus 18 and x minus 3. And so, since this is saying find the coordinates of the point or points, that's probably going to mean that we're going to have one of these two, but of course it is possible that they don't meet at all. So in essence, what we're going to do is I want to just take a look at what this graph would look like and then kind of talk through what we're actually going to do with it. So if we look at this graph to begin with, it will look something like this. Now this was just a rough sketch that I had done ahead of time, but here we've got our green for this one for x squared minus x minus 18. We've got some graph that looks roughly like this. And for this other linear equation, we have one that looks roughly like this. So we can see that the blue line is going to cut through the x-axis at one spot. The green quadratic is going to cut through at two specific spots. And then here in the purple spots was where we are cutting through the, where the linear equation is cutting through the quadratic. Now, what we're going to do is we are going to set up this equation where we have, to find where those two things meet, we have to set these two equations equal to each other. So we're going to have x squared minus x minus 18, and that is going to equal x minus 3. Now, as we're doing that, what essentially are we doing? Well, actually, sorry, let's do this first. Let's start by subtracting our x from both sides. So we have x squared minus 2x minus 18 equals x, equals minus 3 over here. And then I'm going to add 3 to both sides. And finally, I'm left with, I'm going to switch colors here. We're left with x squared minus 2x minus 15 equals 0. So now I change colors because I want to distinguish that this equation is finding these points, and essentially what we are doing is we are finding an equivalent quadratic. This thing here is an equivalent quadratic equation that when we connect this, I'm not making a straight line here, this here, bink, and this here, oh, not quite as straight. These two things here, the one on the right, my scale is off just a little bit, but the one, these things, what happened is I've just created a brand new equation that has equivalent x-intercepts that correspond to where these two cross each other. So I'm basically working with this new quadratic. I don't care what this quadratic actually looks like. I'm just using this method to find where these 2 points cross the x-axis because I know that these two things line up where these correspond. So now what am I going to do? I'm going to try and factor this. This one is easily factorable. So I'm going to do x minus 5, x plus 3 equals 0 because we've got our minus 5, positive 3 that gives us minus 2, and minus 5 times 3 gives us minus 15. So I know that x has got to equal either positive 5 or x has to equal negative 3. So this point here is negative 5, 0, and this point, oh, I have that backwards, sorry. This point here is negative 3, 0. This point here is 5, 0. And what that means is this up here crosses at the point 5 something. And this one over here crosses at the point negative 3 something. So we need to find those somethings. So now that we've found where the x values are, if we want to figure out where the y values are, we can drop this negative 3 and this 5 into either this equation here or this equation here. It doesn't matter which one we use. I'm going to use this one because it's just a little bit easier to work with. So my y value when I have 5 minus 3, y is going to equal 2. So this is going to cross at positive 2. So we can see again, not quite to scale. Maybe this goes up by 2s instead of by 1s. And this one over here, if we've got y equals minus 3 times, or minus 3, so y equals negative 6. So here we go, negative 6. So yeah, it looks like, well, I don't know what the scales are. Oh yeah, that looks about right. Negative 2, 4, 6, and that must be positive 2. So we've got the scales going in 2s here and going in 1s, single units there. So here's our two intersections. Our 2 points of intersection are going to be 5 and 2 and negative 3, negative 6. So there's our 2 points of intersection. Bada boom, bada bing. And so again, what we did was we set these two equations together. We created a new quadratic. This new quadratic was solely to find the x-intercepts, which correspond to the x values of where these two things cross. And then we take those two x-intercepts and we drop them back into our equations to find the corresponding y values. So don't get confused with this idea of there's a new quadratic out here. That's just roughly what we're doing there. All right, so here we've got another one. So we've got two curves here. We've got two quadratics this time. We've got x squared plus 5x plus 6, and we've got negative 2x squared minus 4x plus 6. Now we're going to solve for x. We're going to graph these two things on the same set of axes, and then we are going to solve for where this graph is greater than this graph. All right, so let's solve for x. And so what we're going to do is, again, we're going to do a very similar thing that we did before. Let's have this one. So we're going to do x squared plus 5x plus 6, and that is going to equal negative 2x squared minus 4x plus 6. So I'm going to go through the same process. I'm going to add, I'm going to add 2x squared to both sides. So that gives me on this side 3x squared. I'm going to add my 4x to both sides, and that's going to give me plus 9x over here, and then I'm going to subtract 6 from both sides. Okay, so that means that this thing is going to be plus 0, and that's going to equal 0. So again, what I've done is I've combined both of these two things into one equation, just like we did above. And now I'm going to try and solve for x for this one. So 3x squared plus 9x equals 0. I can see that I've got a common value of 3x in both of these. So I'll factor out that 3x, and I'm left with x plus 3. And that equals 0. So that means either 3x has to equal 0 or x plus 3 has to equal 0. So here on the left, we have x equaling 0 when we divide both sides by 3, and here we get x equals negative 3. So that is solving these two equations for when they're equal to each other. Now it asks us to graph these two things on the same set of axes. Now I've actually already done this. Again, this is just kind of, whoops, I'm just gonna kind of pop this in there. So, oh, I did blue and green. I didn't realize I did blue and green ahead of time, but that's okay. So this one here is our x squared plus 5x plus 6. Here, let's just take a second. We'll just swap out those colors just to keep these things lined up. And over here, we have our blue equation. There we go. Whoops. All right, so we've got our two equations. So again, we have these two things lined up, our green equation here and our blue equation there. So when we've solved for x, so it looks like these things cross at x equals 0 and x equals -3. So x equals 0, x equals here's x equals 0, here's x equals -3. When x is 0, when x is -3. So just like we did in the previous one, in this equation, in this purple bit, this is us creating two equivalent statements or two equivalent graphs that when we line these things up, roughly, again, my lines are off just a touch, but that line and this one over here, they are roughly the same. So if I were to extend this one up, it's kind of hard to see there, but here, if we go up here, because it's going across the x-axis, these two things are lining up here at x equals 0, x equals 0, and here, x equals -3, here, x equals -3. So we've created a brand new purple equation, the purple equation that lines up with the intersection of these two curves, be it linear or be it two quadratics, they both intersect. These could be tangent to each other as well. One could touch right here. In this case, these two things touch at two separate spots, and we have where they intersect here by our x values. So now I want to solve, so it doesn't actually ask for what 2 points do these things touch. They just say find the x values, so I did that here. I graphed them, I kind of pre-did that, but it looks roughly like this. Then now find where this equation is greater than this equation. All right, so the x squared plus 5x plus 6, that is the green one here. And I want to know where is this thing greater than this one. So what I'm trying to do is I'm trying to figure out where the y values for this is greater than the y values for this. Because we know y equals all of this, y equals all of this. So we could also say where does this y, where is this y, which equates to this thing, greater than this y, which is this one. Again, I guess I probably should have done those as blue. Whereas this y greater than this one. So, so where are the green values? Where are the green values, the y values bigger than the other ones? So it looks as though over here, the green is a little bit bigger because it's up on top. And then it looks like if we extended this line out this way, up here, this would also be where it is bigger. So here's what I'm going to do. I'm gonna kind of consider a line here, and I will put on one part of the line, I'm going to put -3, and on the other part, I'm going to put 0. So this is where these two things intersect, right here, right? And so now I'm going to pick some values in between and outside of here, and I'm just going to compare the different values when I substitute them in. So let's start with the outside over here on the left. I'm just going to pick -10. I'm just picking -10 because it seems like it will be an easier number to work with. So as I go and I drop -10 into my different equations, I've got the x squared plus 5x plus 6, and then I have -2x squared minus 4x plus 6. So let's see what happens. So if I drop negative 10 in here, negative 10 squared plus 5 times a negative 10, that's supposed to be a negative 10, plus 6. And then I also want to do negative 2 times negative 10 squared minus 4 times negative 10 plus 6. All right, so here I've got 100 minus 50 plus 6. So 100 minus 50 is 50 plus 6. There's 56. And then over here, I've got 100, negative 200, and positive 40. Well, that's negative 200 is already going to be bigger than this, or that's going to outweigh this. So I'm going to have negative 200 plus 40. So that's negative 160 plus 6. So that's going to be negative 134, I believe. So it's clear that this green one is bigger. So we're going to put green is bigger. So I just put the green is bigger because, you know, I want to just keep track of which one is bigger. And I could do the same thing out here. I could just pick a positive 10 out here. I could pick 1. I could pick anything. But since I already did positive 10, or since I already did negative 10, it makes sense to be just as easy to do positive 10. So I'm still going to have 100. Now instead of, well, we're going to have 100 plus positive 10. So that's going to be plus 50 plus 6. So I get 156. Over here, if I put positive 10 in, that's going to be positive 100 again. So that's negative 200. This is going to be positive 10. So now I'm going to be subtracting 40. I'm going to add 6. So negative 240 plus 6. So that's going to be negative 240 plus 6, 234. So again, on the outside here, I've got green is bigger. And you can probably figure out already, and we can even visually see here, blue is going to be bigger than our green there. So, you know, we could even put that in here. Blue is bigger. And if I wanted to pick any value in between here, I could confirm that the blue is going to be bigger by putting in like a negative 1 in there. So, you know, if you want to do that, you can do that on your own. So that means that green is bigger. The green equation is bigger when x is less than negative 3 and when x is greater than 0. So don't get confused and put in these values in there. Make sure you keep in this is the boundary. And I'm not putting equals in there because when it equals negative 3, when it equals 0, those values are 0. So, or those values are not equal. Or sorry, they're not greater than. They're equal at that point. So this is my solution right here. X is less than negative 3 and x is greater than 0. All right, so the last thing I want to do for this particular set of lessons is this one here. In this, we're going to follow what we did before with the discriminant. And we are trying to find, again, roughly speaking, when we have some quadratic here. I don't know what it's going to look like, but I know it's going to be a quadratic. And I've got some linear equation, and that's going to be going up. It's going to touch here somewhere because it says that this thing is tangent. This is tangent here. And I don't think I have this. Yeah. So we are looking to see where do the two things touch. Now I just graphed it here because it's the easiest visual to see where these two things touch. It looks like it's going to be right there. I don't really know. But what I'm going to do is I'm going to set these two things equal to each other, and I want to find where this equals, where I've got 1 point of intersection. And if I go back to thinking about, well, how did that look when I had just one quadratic? Again, going back to the idea of creating a different quadratic, that would be when I had something that looked roughly like this, where it touches at one spot. So really what I'm doing is I'm kind of thinking about where is this going to happen? Where am I going to get this line to kind of cross over right there? That's kind of straight there. So where are these things going to be equal? Where the intersection point of the blue and green matches up with the one intersection of the purple. And we do that because when we have the discriminant is part of the quadratic equation, remember, and the discriminant is when is the b squared minus 4ac, and we know that when the discriminant is greater than 0, we have two real solutions. When the discriminant equals 0, we have one real solution. And when the discriminant is less than 0, we have no real solutions. So what we're focusing on is this one, where it has one real solution where the two graphs are tangent to each other. So I'm going to set these two things equal to each other, and I'm going to solve for when these things equal 0, and then go from there. So I have 2x squared minus 3x plus 4, and that has to be equal to 2x plus k. And now I'm doing it equal to, again, because this thing is equal here. If it said greater than, like we had up here in this one, where it was greater than or less than, then we could start using and start considering this situation. But here we're looking to see where are these two things tangent. So I'm going to make it where they equal 0. So let's rearrange. So I'm going to subtract 2x from both sides. So I end up with 2x squared minus 5x. And then I'm going to subtract this k from both sides. And that k, that becomes part of c. So I'm going to have plus 4 minus k. This all is c. And we know that whole thing is going to equal 0. This here, remember that's b, and this here is our a. So when we're looking at our a here, here's our b here, here's our b, and our c here, here's our c. So let's drop those things back in. So where it says b squared, so that's going to be negative 5 squared minus 4 times a, which is 2 times c, 4 minus k, and we want this to equal 0 because we want there to be one solution again. So now it's just a matter of doing some computations. 25 minus 8 times 4 minus k, just breaking it down into step by step. Now I'm going to take this, so that's minus 4 times 2. So now I'm going to take this minus 8 and distribute it across here. 25 minus, not 24, that's 32, plus 8k equals 0. All right, so 25 minus 32, what's that? Minus 7, I believe. So minus 7 plus 8k equals 0. Let's add 7 to both sides. And so we're left with, what's that? 8k has got to equal 7. So when we divide both sides by 8 now, we get k is equal to 7/8. So when k equals 7/8, that is when I'm going to have a value where these two things are equal to each other, where they're tangent, and where I have one intersection. So that's how we kind of consider the different aspects of finding intersecting graphs, and I hope that helps.